Hello everyone, this is our video demonstration of the project CS2202 mini project, dbms course, and following the agenda of the video demonstration given in the PDF itself, we'll start with the ER diagram and relation schema. This is our GitHub. This is the ER diagram which we have followed. We'll start with the relations and entities directly. So first of all, we go to the train part. Train has the primary key as train ID itself. Then there's train name types. And train will have sources and destinations from the station table. So station table will have the station ID and other informations like station name and code and city and state where the station is exactly residing. Train will be categorized into different classes. So there will be different classes of the different types of classes of the seats. Then train will have seats. Train will follow a route. So every route will have a route ID, the train ID itself. That is the foreign key itself of the train table. There is sequence, there is station ID itself, and again, then there is schedule. So train will follow a schedule. Will have schedule ID, the train ID itself, which follows the schedule. Then the running days itself. There's another isolated table that is the class which belongs to the train class itself, and again categorizes the seats. Also, it will specify the tickets. It will embed itself in the ticket part. So after train, what our train issues is what we get in a ticket table. So the ticket has the booking ID, the ticket ID, which is acting as a primary key. Here over here, PNR number cannot act as a primary key because there can be cases when PNR number is similar, but the train number is different. So in those cases, there will be a massive collapse of the database. Thus, we have used train ID as the primary key. That is a couple of foreign keys like the booking ID, passenger ID, train ID, all inferencing from the booking table, the passenger table, and the payment table. So, then there's a weak entities relation over here. So if there is a ticket, only then there may be a cancellation on that ticket ID itself, again, which is a foreign key for the ticket table's primary key. This has cancellation date, refund amount, and refund status. Over here, we have a passenger table, which makes a booking, and booking has payment. You can see the attributes of the payment, including ID, booking ID, the amount itself. Passengers can receive a concession, which is inferenced from this concession table. So concession can be different types and different percentage already mapped to what kind of concession ID is being fetched, and that is applied to the passengers via our queries we have specified for it. So this is pretty much the AI diagram. We have used we have implemented everything in the most optimal normal form. So some are in the third normal form. Sometimes we will denormalize for better performance and optimization and consistency, including in insertion, deletion, and updation. So this was our ER diagram. Let's move to the front end portion. So let's dive into the front end application which we have built. So there is already in the backend we've implemented every single query with additional queries also. But in the front end, we'll use this Streamlit application which we have built. We have connected the backend APIs to the Streamlit interface. And then this is our railway application. All right. So here, first of all, we are prompted a user login. We'll start with the login and password. We enter the password. Here. So thus we are logging into the system. All right. We have the functionality to search the train. So whatever data has been populated into our database, we can select the from station. We can select the to station. We start with the Delhi junction. We go to the Bangalore, and then the journey date select. We search the train. So this we are prompted with different trains which are available. This is how we are entering in the front end. We can select which train to book. We can select which class to book, and then we can proceed to the booking part. So as we can see, after the train search, we are directly prompted to the booking tickets. Here we can add our passenger details or whatever details we want to add. So after we fill everything, then there is we get the payment details. If we apply for concession, the concession will exactly be applied as it is. Yeah. So yeah, as you can see, the concession has been applied. Okay, so 50% concession has been applied over here. The payment method is also given. So in case we further plan to scale this product, so we'll also be adding the payment gateway portal into it for the later part. There is net banking also available. There's UPI also available. We have to connect it just to the payment integration section. That's it. Then there is option to check for PNR status. So we can give we can give PNR number, and then we can check the status of the train. Yeah. So as you can see, this PNR belongs to this train, which is the type, and everything is properly functionally mentioned, the fare details, including the fare details as well. Yeah, all right. Then you have the ability to cancel the ticket by simply entering your PNR number. Since you are logged in the user, you just need to enter your PNR number. We search the ticket. If you find a ticket, you have the option to actually cancel it. So yeah, just confirm. There will be some cancellation charges definitely. Since it is waitlisted, there's one ticket which is waitlisted, there's one ticket which is confirmed. So obviously there are different rates of cancellation for waitlisted and confirmed. This also we have implemented in our logic. And as we see, we can simply cancel. Already it's cancelled. Then we can check our bookings, whatever upcoming journey bookings, bookings, whichever is there. We can go for past journeys as well. Whatever past journeys from and to station, and we can select. Okay, yeah, these are the details. These are the upcoming retail journey which we recently booked. So this was pretty much our interface in the front end, which is ready to deploy just with a click over the Streamlit application, and the backend is properly working. Now we'll dive into the queries and detailed explanation of each and every queries.
Procedure to book a ticket, like we have taken input as a passenger ID, train ID, and others which we can see here, and we have declared variables, variable fare, variable distance, which we will use later. First we have calculated distance as a distance from where we start and distance from where we end. We have joined the route on train ID, and conditions are train ID matches with train ID, station ID matches with station ID. Then we have calculated bear fee, like we have calculated the total distance we travel, and average total and average fee we have taken for the calculation. We have applied concession if applicable on the fare distance. Then if the concession is applicable, then on the basis of the current date we are traveling. Then checking seat availability of the train where we have been traveling on the basis of train ID and the train class. If seat available, we have confirmed. If not available, we have find the seat if it is available or not. Update the seat confirmation if it is available. Otherwise, check for RAC if it is available. Then we have generated PNR number. Then we have created the booking on the basis of that. Then set record payment the way we have done the payment, and then we have update the seat records, like if the seat is confirmed, we have decremented the seat number. If it is available, we have incremented that. So for cancellation we have created a trigger so that the ticket table will be updated according to that. So we have declared I've declared some variable which we will use later, and selected the columns which we will use. So update the ticket which we have to cancel, and here if it is available, and make the ticket available which we are cancelling, and the number of seats will be incremented since a passenger is cancelling his ticket, and RAC will be updated according to that. The line of the RAC will be lined if the particular ticket is a RAC one. If found, cancel it. Say ticket number is available, the particular is cancelled, and update the ticket booked. Function to calculate fare with concession. Again we have declared the variable which we will use, and distance is calculated, like from where we start and where we end. Get a bear fee, like we have calculated the total distance and the average fee on the distance, so we are getting the total fee. And concession is applicable if the journey is if the journey comes beyond that current date, and add the subtract the concession from that and give the total fare. Yeah. So for the PNR number tracking, we have joined ticket table with passenger table, train table, class table, station table, and the condition is the PNR number matches with the PNR number of the ticket which we have to display, and we have called, and here is the output for that. For train schedule lookup, we have taken input as a train ID and joined the table route with train table and station table, and the train ID matches with the train ID of which we have for the schedule we have to display, and ordered by the sequence number. Now coming back to available seats for the train and the class we have to look for, and we have taken input as train ID, class ID, and the journey date, and then we have taken conditions as a train ID matches with the train ID, and class ID matches with the class ID which we have to, and the journey day matches, and the seat should be available for that. And here we have called for the train ID as 1, class ID as 3, and date 6th of January, and this is the output. And for passengers on the train, we have taken input as train ID and the journey date, and we have joined the table train ticket with passenger table, class table, station for the arrival, and the station for departure, where train ID is the train ID for which we have to output, and the journey date, and the ticket as confirmed. For the list of the waitlist passengers, we have taken input as train ID and the journey date for that, and then we have joined the ticket table with the passenger table, booking table, and the station from the arrival starts and from the journey ends. And the conditions are train ID matches with the particular train ID, journey day matches with the particular journey date, and the ticket status should be waitlist and ordered by the booking date. Now we have to calculate the cancellation refund. So we have we have to accumulate all the refund amount. So from the cancellation list, we have joined ticket table with and train ID matches with the train ID, and date of cancellation matches with that particular cancellation date. Now we have to give revenue report. Total revenue calculated as sum of all the payment amount between the particular dates, and the payment status should be successful. Revenue by payment mode, like we have to calculate particular payment amount received by particular payment mode. So we have accumulated all the payment amount according to the particular group by the particular payment mode, and the revenue by particular train. So similarly, like that we have done, accumulated all the payment amount, and payment status should be success. Just we have done different is like we have grouped by train ID in this part, and we have generated the report according to the input. Now coming to the cancellation records, similarly we have done we have taken the start time from where we have to record and the end date, and join the cancellation table with ticket table, passenger table, train table, where cancellation date should match from the start date and end date, and ordered by the cancellation date. And here is the output. Now coming to the busiest route, we have taken the start date and end date as input, and taken the count of the passenger count between the source destination and the final destination, and we have grouped it by station ID and station ID from arrival station and the end station, and ordered it descending order according to that, and limit is 5, so we get the display of top 5 station. Now ticket bill generation. So we have taken all the variables we have to display as, and join the ticket table with passenger table, train table, class table, and the first station from where journey starts, and the second and the last station where journey ends, and the PNR number matches with the particular like we have implemented some interesting queries which we are assigned, like find a train with most cancellation, like we have counted all the cancelled we have calculated all the cancelled tickets, and group it according to the train ID, and ordered according to the most cancelled one. Like now second one is average age of passenger according to the, so we have calculated the average of the passengers age, and then group it by the class ID, and then ordered it descending order. Now calculation of revenue by payment mode. So we have accumulated all the payment amount, and then group it by according to the payment mode, and then we have made it descending wise. Most popular travel class. So we have we calculated the count of the ticket, and then group it by class ID, and then make it descending order, and then limit it by 1.